The comparable interface is an example of an existing interface in Java. This is used to indicate that objects which implement this interface can be compared one to another. It's a generic interface in the sense that it has a generic type E which will be replaced by a specific concrete type when you actually implement the interface. In other words, E is a placeholder for some particular type. The comparable interface looks like the code that you see here. Public interface comparable, and then we have our generic type E, and then there is an abstract method, public int compare to EO, meaning O is an object of this generic type E that's expected as an argument to the compare to interface or the compare to method. An integer should be returned in this case, and that integer we will see in the next slide has a certain particular meaning, or in a few slides at least, about how it's interpreted. But one glimpse of what's coming is that a 0 will indicate equality between the two things being compared, and we'll talk about the other possibilities when we get to that point in a few slides. The comparable interface is not for primitives. We already have operators for comparing primitives for equality and greater than and less than and not equal, for example. But those operators do not work with objects, and that's why we need some comparable method in order to compare them. And the comparable interface exists just to indicate that objects that implement this interface are in fact comparable. And as a side effect of this, we would provide an implementation to show how to compare objects of a particular class. Again, bearing in mind that this is not something for primitives, but only objects, then we can talk about the objects, the wrapper classes that represent primitive values, that is byte, short, integer, long, float, double, all with capital letters here to make sure you understand that these are classes. And all of these things are comparable. They all implement the comparable interface. Characters are also comparable, and that class will implement the comparable interface. Of course, BigInteger and BigDecimal also implement the comparable interface. And finally, calendar, string, and date are other examples of things, objects, classes that implement this comparable interface. Of all those classes on the previous slide that implement the comparable interface, we're now going to look at a few of them, 4 to be precise, and show how they actually do this syntactically. So starting with integer, that's the top left corner here, we would say public class integer, and again remember this is the wrapper integer class, extends number, which is the parent class of all the wrapper classes, and implements comparable, and notice the generic type has been replaced by the wrapper class integer as a type. The actual class body has been omitted here, but we now go down to the place where we're overriding the comparable, or rather the compared to method. So we say public int compared to integer O. So this is going to be an implementation which has also been omitted here, but this will tell how we compare two wrapper class integers. And you can imagine how this is going to work. You would have to unbox the two arguments and then take a look at the primitives that are inside, and then use the traditional equals operator and greater than and less than and so on to actually do the comparison and then return an appropriate result. And we still haven't talked about what that result is going to look like, but that will be a subject for the next slide in just a moment. In your study time, you can look at the remaining 3 blocks here. The way that this works with big integers and strings and dates is similar to the scenario I just went through with you in the case of the wrapper class integers. So I'll let you have a look at that on your own. Now finally, as promised, we're going to look at the interpretation of the output generated by the compare to method. That interpretation is going to depend somewhat on what we're comparing to what. So let's take a look at the first example. Up at the top, you'll notice that we create an anonymous wrapper class object integer because we do a new, but we don't give it a name. So we're wrapping up 3, and then we're doing a dot compare to, and then we're doing another anonymous wrapper class integer 5. So we're comparing 3 to 5. What will happen in this case is we will generate the result -1. If you look down on the bottom part of the slide, you see that the first output is a -1. If it had been a 0, that would mean that the two objects were equal. But in this case, minus A -1 result, in fact, means that the first object is less than the second. Now, if you look at it, that's obvious. 3 is less than 5, so you would expect that as output. If, on the other hand, we were to swap the positions of the 3 and the 5, then the result would be +1. So now you can see that the implementation is such that a 0 represents equality, a -1 represents that the first is less than the second, and a +1 would represent that the first is greater than the second. This interpretation is a little bit different in the context of strings, however. So our second example on the slide, where we're comparing ABC as a string to ABE as a string, then in fact we get a -2 in this case, and that deserves some explanation. Well, first of all, if the strings were identical, for example ABC and ABC, then we would indeed get a 0, as you might expect. Now, the reason we get a -2 when we compare ABC to ABE is that we go through the strings one letter at a time till we find a mismatch, and then we subtract the ASCII code or the Unicode value for the first mismatch character against the second. So in this case, it's the C and the E where the mismatch is occurring. We take the Unicode value for C, subtract the Unicode value for E, and that value comes to -2, and that is what we display as our final output for that case. So the interpretation is a little bit different with strings than it was for integers. Now, in the case of the dates, it's more like the same way that we would have compared the integers. So in this case, we have two dates that we're comparing one to another. We set up date number 1 as being January 1st of 2013. We set up date 2 as being January the 1st of 2012. And then we compare the two dates together by saying date 1 dot compared to date 2. Date 1 is a newer date than date number 2, and so to capture that we have a +1 as output. In the case of comparing dates, we're only going to generate one of three results, either +1, -1, or 0. Obviously 0 in the case that the dates match, +1 in a case like this where the first date was newer than the second date, and -1 if the opposite situation had occurred. In the previous slide, we were working with objects of the wrapper class integer, string, and of date. And obviously, in all cases, these classes implement the comparable interface, and that means that objects of these classes are all instances of comparable as a result. You can see that in all three of the charts that are shown at the bottom of the slide. On the last entry in each case, n is an instance of comparable, and n was an integer object. S was an instance of comparable as a string, and D, which was a date, is also an instance of comparable. Up at the top of each of these boxes, we have each of these things being shown as an instance of their actual native type, integer in the case of n, string in the case of s, and D in the case of date. So D is an instance of Java util date, S is an instance of string, and N is an instance of integer. That would probably be very obvious. What might not be completely obvious is that these are all instances of object as well, and that is because of the is-a relationship that exists between subclasses and classes, or in other words, between children and parents. So because integer is a subclass of object, anything that's an instance of an integer, or wrapped class integer, is also going to be an instance of an object. Likewise, anything that's going to be a string is also going to be an instance of object as well, and so on. So none of what you see in these three charts at the bottom should surprise you at all.